The concept I'm going to explain today is the annuity immediate. You may not know what annuity is, so let me tell a story to lead you in. Imagine you won Lotto a few hours earlier. Here are two rewards from which you can choose. Reward A is to get $12 million immediately, and Reward B is to get $1 million per year for the next 20 years, payments starting 1 year from now. Consider the time value of money. You know you can get 5% by depositing your money in the bank account. You can consider the Reward B as an asset that pays a fixed amount of money each year for several years. 12 million is a big prize, isn't it? But people always want more. Will the prize B exceed 12 million in total? How to choose between the two prizes? Let's work it out. At first, we want to know what annuity is. An annuity is a series of payments required to be made or received over time at fixed intervals. And an annuity immediate is one kind of annuity when the payments are made at the end of the time periods. Let me give it in another way. My little brother Mike loves candy bars. Mom promised to give him one candy bar every day for a whole year. We want to know how many candy bars Mike actually gets at the beginning of that year. In this case, candy bars become the payments. The most common payments intervals are yearly, semi-annually, quarterly, and monthly. And these are some examples of annuities: mortgage, car payments, rents, pension fund payments, and insurance premiums. It seems that annuity appears everywhere, so it's very important to us. Next, let's learn the several features of annuity: the amount of each payment X, interest rate I, the number of terms N, and the frequency of payments. Let me use a graph to illustrate this. From today, you get X dollars every day until the day N, and the interest rate is I. Discount those X to today and sum them up. We find it's a geometric series. X over 1 plus I is a common ratio Q. The expression can be simplified using the summation formula. We can further simplify it to the last version. And the term in bracket is called annuity immediate PV factor, which is denoted as A angle NI. Since we get the formula, we want to know which one we should choose for the Lotto. For the next 20 years, get $1 million per year and the interest rate is 5%. Using the formula, we get the present value, which is equal to 12.5 million, and it's bigger than 12 million. So we should choose prize B. Now we'll find out the relationships among those features and the present value of annuity immediate. The first one is X. When the payments become larger, we get more in every term. That's what we want. When the interest rate gets higher, the denominators become bigger. Each payment is discounted to smaller PV, thus the total price decreases. The third one is N. When N gets larger, we get payments for more years, hence PV increases. So how about frequency? $7 a week or $1 per day, which one do you prefer? Consider the mortgage you are paying. If it is paid yearly, then the 5-year mortgage, each payment equals $1,1200. The interest rate is 12%. PV is equal to $43.26. If it is paid more frequently, for example monthly, then N is 60. Interest rate is 1% and each payment is $100. After calculation, the answer is $44.96, which is bigger than $43.26. That is to say, if a mortgage is paid monthly rather than yearly, you pay more. In this case, we finally get the relationship between the frequency of payments and the value of annuity. That is, PV is positively related to frequency. Thank you.